Today we're going to do a short coverage of ethics. This is in the book. It's in the beginning of the book because it's really important, but here it's at the end because we have labs, and I wanted to teach you how to do the labs. Humans have been on the earth for tens of thousands of years, however you want to count it, and we're special amongst the animals. We're vicious, we're mean, we're predatory a bunch each other. If you don't know that, you know, just count how many wars we've had in the last 30 minutes, right? But as engineers, our job is to put aside our basic survival instincts, because we are charged with creating devices that do go into safety critical environments. And so if you look at right and wrong, that's the essence of morals, and that's a sociological discussion, which we are not going to have today. Find somebody in your life who you respect and have these kinds of discussions. But we're not talking about morals. We're not talking about religion. We're talking about engineering, okay? And that's doing the right thing when we design. And as we've said along, when you mess up, somebody dies, okay? The consequences of you violating some of these ethical things might be catastrophic. Okay, so we're going to talk about the actions in a particular group. That's the essence of ethics. And this group is obviously engineers. Okay. This is the IEEE Code of Ethics, and I would just like to point out the first one: act responsibly and responsibly. This is the one that is on the test, by the way, and we're going to talk about what that means. Conflict of interest. As you know, Pierce and I started a company. It's called Admittance Technologies. We're in clinical trials for a medical device. And it is in my best interest to be a liar and a cheater when I publish papers on the, in the IEEE journals. Because if I were to do so, I might earn more money as a stockholder for my company. That's a conflict of interest where I have the risk of doing the wrong thing. What we do here at the University of Texas is we manage the conflict of risk by identifying it. For example, when I write a paper and I submit it to the journals, I have to disclose that I'm a substantial stockholder in the company called Admittance Technologies, okay, which is related to the paper. I have to have meetings with my chairman to talk about how to manage my graduate students, because graduate students should have free will to do research without the thumb of Valvano wanting to earn money for his company. You know, I can't make them Xerox, and I can't keep them from publishing, and I can't do all the things I might want to do. So we do have a conflict of interest. That's not a bad thing, but what we want to do is manage it. In other words, bring it to the surface and talk about it. Because it's also not in my best interest financially to lie and cheat on my papers, by the way. I don't know why anybody would do that, because that's not going to make them money, because somebody's going to figure out you lied and cheated, and then you're not going to make any money. Honest and realistic, you know, obviously bribes are bad, although, you know, if bribes are bad, why do we have lobbyists, by the way? My definition of a lobbyist is a professional briber. So, but to say it doesn't exist is unfair. You know, companies take you out to dinner and they pay your, you know, they pay your meal. That's a form of bribery. Okay, a grad student doing their, I'm talking to you, Yunshin, doing their defense, brings food for the professors. Bribery. Okay. So when I go to a PhD defense, I have to wait long enough into the defense to decide how I'm going to vote, and then I'll eat the cookies. And since I've already made up my mind I'm going to pass or fail, the consumption of the cookies don't matter. Okay, so competence, these are all good things. Okay, these are all good things, and they should be posted in your life as an engineer. Okay, so let's do some scenarios. This comes up a lot, and that is this is a scenario where you work for one company, and you discover an algorithm on the web. Okay, so this is all. There's a couple of these. Says how do we deal with stuff posted on the web, and this information is greatly useful for the product you're trying to develop. Okay, so this is a typical scenario. Is it possible or is it ethical to copy the code? Okay, is it? Okay. And you have to realize that this is a two-step process. Okay, the first is the code itself. Okay, and the second is the algorithm. We're going to do them separately. If the code, you contact the author the best you can and ask for permission. Okay, now as you notice my code, when I post code on the web, I make it easy for the world to decide what to do with it when they're in that spot. I say it probably doesn't work, but you can use it for whatever you want. Okay, don't blame me. Okay, because obviously responsibility, remember that's on the test, means you're going to have to test it anyway. And what if you get to the scenario, and that is they say this is free for educational use but not for commercial use. Okay, that happens. So I don't know why they don't like us making money, but and so you might find code that's available for looking at for private non-commercial use, but not specifically restricted for commercial use. Okay, and now that flips us over to the algorithm. Okay, and now what we're going to do is we're going to do a patent search on the method they used in that software. Okay, and if they have patented the method, then we got to buy the patent or lease the patent. If they hadn't, because that's why it's there, we negotiate for that patent. If it's not patented, then the algorithm is available for me to recode, to re-engineer, to redo. Okay? So it's good practice, obviously. And you know my rule about copying code to the internet: don't take anybody's name off. Okay? So you can add your name to it, but don't take their name off. Okay. Again, how does responsibility interact with this copying code off the internet? Okay. Again, you are delivering a product. You are responsible for its testing. Okay. Now, if you purchase the code, okay, often you purchase code. We got some examples of purchasing code a little later. Then you might have some expectation about whose responsibility it is to test that code. But if you're just downloading off the internet, it's clearly your responsibility. Okay, I already answered that one. Okay, so the ethical use of a program which says cannot be used for product sale. Again, the answer to this is we'll look for the algorithm, and if it's patented, we'll license it. It's a gray area, by the way. That's why the lawyers get paid a lot. Okay, how different does it have to be to not have to use the license, and how good your lawyer is? Okay, this happens. This happens a lot, and I'm not going to tell you you're going to get fired from your first job, but you might. Second job, third job, fourth job. People move around a lot. It's a very healthy thing, actually. And so my charge to you when you go to work someplace, go into training mode. Say, 2 years from now when I get fired, well, it's not going to be your fault. The company will go in a different direction or whatever. I want you to be more educated than you started. So I want you to learn techniques. And one of the problems that companies have when they don't want to fire you, but you can learn a process, okay? And so, for example, we learned some processes in this class. It's like how to design an op amp, with 7 easy steps, or how to design an analog filter, or how to lay out a board, or how to go through the manufacturing process of creating a system, right? These are processes you learned in this class. When you work for a company, you're going to learn how to go through the steps of engineering, manufacturing, design, test, etc. That's a process, okay? So that you do step A, you heat it up to 20 degrees, you heat it down to minus 20, you heat it up to 100, you heat it down to minus 200. Yeah, you didn't get to minus 200. Back and forth, that's a process for seeing if it will crack under heat stress. Okay? These are processes that you might be learning. And now you've left this company. You didn't develop the process. It's not your process, but you learned how to do it. Okay? Now you're working for another company. Can you use this procedure, this process? And the answer is absolutely yes, because it is just like learning. It's part of your knowledge. It's part of your education. So again, if you distill your now to know that this torpedo oscillates at 4,000 RPMs, 40,000 RPMs, that's a technical secret. That's probably not disclosable. Okay. But to learn how to do something that makes you more efficient, how to debug code, how to develop code, how to test code, etc. Those are all things you can use. Yeah. All right. Again, since this is a very common, problem, what you will find is that when you start a job, they will make you sign a disclosure agreement. An agreement that clearly specifies the boundary between general education and company secrets. Okay? So there will be a clear line, and if not, then you could ask for a clarification before you sign it or whatever, before you learn it. But generally there are some guidelines from your employer, your previous employer, about how you would make this decision about this procedure, whether or not you can. But if it sounds and feels like this is how you design an op amp, yeah, then that's generally not something they can keep you from ever using ever again. All right. This one happens. This one happens a lot to new engineers, and you're in the test mode because that's what new engineers generally do. Okay, and I've asked this question on the exam too. What do you do here? You don't start with the newspaper. Okay. Here's my rule of thumb. I'm usually wrong, by the way. It's a humility thing. Whenever I see something, my first guess is I must be seeing things. Okay, and this is generally true about issues of ethical consideration, and that is you have your eyes open, but your first step is to talk to your boss or a coworker. Or you go to the company procedure that tells you which one should I go to first. Should I go to my coworker? Should I go to my boss? So if you identify what you think is a compromise in safety, you will talk to your boss. Okay? And then get more people into the circle as you decide. Now most companies will have a procedure if your boss doesn't agree with you. Okay? You still think it's so they can't convince you that it's not safe. They think it's safe, you think it's unsafe. There should be a procedure for you to bring it up to their boss. Okay? But you probably, unless it's an Enron kind of thing, you're probably not going to the newspapers. Okay? Because it's generally that's a pretty much an outline. All right. Along that same line, here's a real story. Okay. What do you do when a part goes obsolete? Right. You make a new one. Okay. And so you'll find that a lot of embedded system solutions are plug-and-place replacements for existing parts you can't get anymore. So you're a young engineer, and here's the part you're trying to replace. It's got two input. One is called propeller, and it's a pulse. Okay. The other is called reset, and it's a button. Okay. So the propeller is connected up to a sensor on what you believe to be a torpedo, and it's got one output. Okay, called arm. Okay? You might kind of guess what arm might do to a torpedo. And the problem is, in order to make this safe for the ship, they have a safety feature in the torpedo that it must turn, whatever, 100,000 times, okay, before it arms. Okay? But sailors down underwater with nothing to do like to twirl the propellers, because it's sitting there and it will twirl if you wiggle your finger. It makes a nice. You ever seen somebody grab a motor? What's the first thing they do? They start spinning it because it feels good, right? It's like a. So the original designer of this safety feature put in a reset button, so that before you launch the torpedo, you could hit the reset button, so it doesn't blow up right there outside, inside the ship, right? So, but your job is to test this part, but you notice a flaw, that if you're holding the reset button while you twirl the propeller, the arm goes high. During the test, you're replacing, you're doing a test to make sure your part does exactly what the other part does. That was your job. Go in there, come out with an exact pin per pin performance replacement of this part. And you go, hey, that might not be good, right? You got two sailors, right? One twirling, the other holding the reset button, and the thing goes off. So you go to your boss and you say, should I fix it? Won't cost, it's one line of code, right? Should I introduce that mistake into my embedded system solution? Yes or no? So either way, it's going to cost you, 30 seconds of coding time, and it's not going to cost you any money to fix the bug. Should you fix it? So give me some reasons why you would fix it. Obvious ones. You don't want anybody to die, and it's probably an ethics rule. Nobody should die, right? But there are actually a long list of reasons why you don't want to fix it. And that has to do with you were charged with making an exact replacement. Do you know why?
Charge the government a lot of money?
No. It's, you can charge them more money to fix it, turns out.
Okay.
If you have a system, and if I can't get a part anymore, I'm going to go buy an exact replacement. Exact replacement. There are companies that do that. They just they look at obsolete stuff and they make something exactly certifiable, identical to that part. And that has to do with testing, right? When you built, if let's say you wanted to make 1,000 of your Lab 11 projects, you'd have to test one and then build them all exactly like the first one. Okay? And then you wouldn't have to test them with the exact amount of rigor that you did the first one. But if you replaced the op amp with the op amp of a different type, okay, you'd have to retest it. If you replaced the microcontroller with a different one, if you changed the clock speed, if you did anything major to it, you'd have to retest it. And now people are going to get real grumpy because you replaced one little part in a very complex system, and that whole system has to go through retesting. It's going to cost you time and a significant amount of money. So what did you do? And it's like all the shade of gray. There's no, you put, and it's sad. You put a dollar amount on the cost of the accident, and think about all the costs of a torpedo blowing up inside the machine, inside the boat, a ship, right? People die, ship gets damaged, your company don't look good because there'll be an investigation. It'll come down to this piece of paper that you're going to sign today that said, I just saw the mistake, I chose not to fix it. Okay? That's a cost, a significant cost. But now I'm going to multiply that times the probability of the accident. Okay? And then I'm going to weigh that with the cost of fixing it. Because I will promise you, your company, it's a lose-lose situation, by the way. Because if you choose to fix it, you're going to have a horrible reputation amongst your, amongst your coworkers and your clients, because now you've thrown the whole project 6 months delayed, right? You've thrown the whole thing out of whack. So that's what I mean by it's never easy. The easy ones are easy. Okay. So the question I'm most likely to ask is centered around the first code, and that is take responsibility. Let me give you an example of an employee which did not. There's another real case. Did not accept responsibility. Okay, you write some code, and you develop code and you sell it, right? And this code goes into safety critical environments, and so your customer, the person who bought your code, asks your company, did you test for the condition X? A reasonable question. Okay? People are devious, by the way. Whenever they ask questions, they have an agenda. I'm just telling you. And your boss's boss goes to the company, goes down the train. The boss, being responsible, right, asks somebody, well, what's the answer? That person didn't know, so they post it to another person who didn't know, who posts it to another person, eventually shows up on your desk. You're the one who's supposed to know. Okay? Responsible, right? You're the one who wrote the code. Okay? So you open up the header file, and there you see, if condition X, then whatever. True. So yeah, I wrote code that tests for condition X, send it back up the chain, customer comes back to your company again. Well, what about if condition X and condition Y are simultaneously true? Okay? Did you test for that? And now, boss goes to the boss, goes, well, you're way too busy. The mistake happens. 2 mistakes have already happened, but you go, yeah, I must have. So you say, yeah. Goes back up the chain. Customer now getting mad because they know it doesn't work. Okay? Their system's not working, and they think it's your fault. Okay? They're not sure. It's complicated. So it comes back again, and you get dragged in the room. And not only did you not test for Y and X, when you go into the C file, all there is a stub. Because that's what you do when you develop code. You take the header file, copy it into the C file, and just put little braces around it, and to be filled in later, right? Because you're doing this top-down design. Not only did you not take responsibility, you didn't you didn't do it. So you got to be very, very careful when you sign your stuff. You got to. That's why it's expensive, by the way. Real stuff is expensive because it takes somebody to actually do it. All right, so let me just summarize this part, and it's hard. Ethics is hard. And what I like to say is I put in my life I have a set of people in my life. My mom, my dad, my grandma, my grandfather, my wife, who's actually extremely ethical, and I think about them when I'm making decisions. Would I be proud? Could I look them in the eye and say I did the best I could? Okay, and so, or am I going to be one of those, hide in the back, not want to face it? So I think about my mentors in the ethicals, and then obviously it's complicated. So get help, increase the. I wouldn't go to the newspaper again because I think that's never a solution. I mean, it's very seldom a solution to pick up guns and start shooting each other, right? That's not, obviously people think that's an answer. But I do think engineers are agents for good for the following reason, and that is ethics in engineering actually makes more money than being unethical, by the way. It's actually a cost-effective way, because lying and cheating is often short-lived. I mean, and so be an agent for good. Go out and make the world a better place, because it's hard. Okay.